How do you determine how many roots an equation has? For example, if you see an equation like x to the fifth power minus 1 equals 0, how many roots does it have? Some students might say, well, x to the fifth power must equal 1, right? Move the 1 to the other side. So x equals 1, doesn't it? Isn't that just one root? That's incorrect. The number of roots an equation has depends on the degree of the expression. What degree is it? If it's a fifth degree equation, it must have 5 roots. Everyone, why do so many students not understand this? If it's a fourth degree equation, it has 4 roots. If it's a third degree equation, it has 3 roots. Why is that? Let me prove it to you. Suppose we have an equation x minus 1 equals 0. That's first degree, right? So it definitely has only one root, x equals 1. Okay, what about x squared minus 1 equals 0? That's second degree, so it definitely has 2 roots. What are these 2 roots? This can be factored into x plus 1 times x minus 1 equals 0. So one root is negative 1 and the other is 1, right? Aren't those 2 roots? X equals plus or minus 1. This is a quadratic, so there are 2 roots. Now, what about a cubic? X cubed minus 1 equals 0. How many roots does that have, everyone? So how many roots does it have? Some students might say, isn't it just x cubed equals 1? Doesn't that mean x equals 1, so there's only one root? That's wrong. Besides x equals 1, there are actually 2 more hidden roots. Where are those 2 roots? Let me show you. Isn't this the difference of cubes formula? The original expression can be factored into x minus 1 times x squared plus x plus 1 equals 0, right? Isn't this the difference of cubes formula? That's exactly what it is. So one of its roots is x equals 1. That's correct. One root is x equals 1. And where are the other 2 roots? They're right here. Who are those 2 roots? Can't we just use the quadratic formula to find them? What are those 2 roots? It's negative b over 2a, and negative b is negative 1. Plus or minus the square root of b squared minus 4ac. b squared is 1 minus 4 times, isn't that minus 3? Negative 1 over 2 plus or minus the square root of negative 3. These are the other 2 roots. Of course, the square root of negative 3 is an imaginary number. So it has one real root, which is 1 and 2 imaginary roots. So altogether, how many roots does it have? Isn't it 3 roots in total? All right, then some students might ask, what about a quartile equation? Does a quartile equation have 4 roots? Let's check it out. Let's see if a degree 4 equation really has 4 roots. If x to the 4th power minus 1 equals 0, does it have 4 roots? Can't we factor this as well? Factor it into x squared plus 1 times x squared minus 1 equals 0. Right? Isn't this just the difference of squares formula? Isn't it x squared squared? X squared plus 1 times x squared minus 1 is x to the 4th minus 1, isn't it? No problem at all. And then we can break it down further. X squared plus 1 times, this part is x plus 1 times x minus 1. See? This is also the difference of squares formula, so it turns into this form, right? This thing, aren't these 2 roots? Look, negative 1 is a root and 1 is a root, so that's 2 roots, right? And there are 2 more roots here. What are these 2 roots equal to? That is x squared equals negative 1. So the 2 roots are x equals what? The square root of negative 1. Do you understand this reasoning? What are these 2 roots here? These 2 k's just happen to be equal. Actually, they are 2 roots. It's just that the 2 roots are equal. So according to this rule, a 5th degree equation definitely has 5 roots. If I have time, I can find all 5 roots for you. Some students still have a question. Why, when I was in school, did they say that sometimes there is 1 root and sometimes there are 2 roots? Let me explain this to everyone. X squared plus bx plus c, a quadratic equation in one variable. Right? Some students say that sometimes this function has no roots, sometimes the graph has no intersection points, sometimes 1 intersection point, and sometimes 2 intersection points. Sometimes this situation occurs. What does that mean? It means that its roots are generally explained as negative b over 2a plus or minus the square root of delta, right? So there are 2 roots, but if delta equals 0, these 2 roots are equal. When the 2 roots are equal, they are still 2 roots. Do you understand this reasoning? When the discriminant is 0, when this whole part equals 0, the 2 roots are exactly the same. So people say it's 1 root, but actually it's 2 roots, 2 equal roots. So what if this is less than 0? If it's less than 0, then the roots are imaginary. There are 2 imaginary roots. And if it's greater than 0, then there are 2 real roots. So according to this rule, an equation of degree 5 in x must have 5 roots. When I have time, I'll help you find out exactly what these 5 roots are, everyone.